Well, it might be more accurate to say we like to think that we're a anarcho-syndicalist movement. So I'm talking about BiblioBox, a library in a box. This is gonna be a lot more sort of low level and technical than most of the presentations you've heard so far. But it's a really cool toy, and you need to talk about your toys every so often, I think. So this project, I'm going to start with the history. I'm going to talk a little bit about what I'm trying to do. I'm going to talk about some of the individual pieces of technology that are involved in this, and then I'll show you what it looks like in a very static way. I've got screen captures, and I'll talk a little bit about why it's all static right now when I get there. So this started with a project called Pirate Box. And you can see there's a lunchbox there with the skull and crossbones in the background. In the foreground, the skull and crossbones on this guy's phone. The Pirate Box was created by a fellow named David Darts, who's a faculty member and an artist at NYU. And he had, it started with a problem that he had. He wanted to share media with his students in his art class, and the campus network really wasn't up to it at the time. So he created this standalone thing that he could carry around, which was a wireless router and a hard drive, and he just plugged it into a wall, and it provided an access point that his students could use in the classroom for downloading content. And his students started sharing media through this thing between themselves during class, and he started thinking about this. And he calls the Pirate Box he says that it solves a technical and social problem by providing people in the same physical space with an easy way to anonymously communicate and exchange files. This obviously has larger cultural and political implications, and thus the Pirate Box also serves as an artistic provocation. He says that the name Pirate Box is provocative, and it obviously is, but what he's trying to do is bring about a discussion about the idea that people that are together in the same place like to share stuff, right? It's like when I've got books, I hand books to my friends, right? Used to swap mixtapes or mix CDs, and the Pirate Box lets you swap media, but it's not swapping media indiscriminately across the whole internet. It's a community that develops around one of these things. So it's a standalone Wi-Fi access point running on a router. There's a battery in there, and users can upload and download content. There's a chat function that's built in, so you can chat with each other through, it's like a web-based chat thing that's running on the web server on the router. And it's completely anonymous. The router, the software on the router is not logging any information about the users that are using it, so you share stuff, and then you go away, and there's nothing associating you with what happened on the router. The router has no idea who you are or what you did after you're gone. And it's not connected to the internet. It really is standalone. When you're connected to this, you're not connected to the internet. You can't, be downloading files from this and then go check Wikipedia or something else. It's one or the other, which makes development somewhat challenging. So Jason Griffey, who's at the University of Tennessee in Chattanooga, heard about this project somewhere, and he thought this was really cool, and he came up with his project, Library Box. And he basically took the Pirate Box software and simplified it. He stripped out the chat function, and he disabled the ability for users to upload content. So the operator of the device can put content onto it and then take it someplace, and it's a distribution point for the content that the operator has chosen to get rid of the whole pirate thing completely, because Jason's not really that provocative a guy. And Jason has been really active about talking about this project. So there's a few of us that are working on it. John, you've got, yeah, so John Fink at McMaster has been playing with it a little bit, and there's a few other people that are playing with it. Jason got email from somebody in a country that Jason has been really careful not to name, but if you go and look at the map that Jason's got on the Library Box website that he operates, there's a pinpoint in somewhere in China and he got email from somebody saying that, I'm teaching English to people in this park in this large city that I'm not going to mention, and he thinks that the Library Box is really great because what he does is he loads texts onto the Library Box and takes it to the park where he's teaching his casual English classes. And the students, they don't have computers, but they've all got cell phones, and it's very common wherever they are for cell phones to have Wi-Fi built in. They're not necessarily smartphones, but they've got extra connectivity like that. So the students can download their English practice texts from the Library Box, and it's completely disconnected from the internet, and so there's no possibility of government snooping. There's no possibility if the Library Box is seized. There's no way to track who is using it through their devices or anything like that. So it's being used in a lot of different ways. And you can see that it's really small, right? We've got the Library Box. The biggest thing here, let me see. So this big gray box over here is a battery, one of those power packs that you can get for mobily recharging your iPhone, which is basically just a really big battery. And you can run the Library Box with this hardware configuration for 15 or 16 hours, providing service for a local area. So when Jason tweeted about this back in December or January, I thought this was a really cool thing. And I was feeling like I hadn't been doing any programming for a while, and I wanted to do something, and this was neat, and it was cheap. So my objectives for this project were to learn a bunch of stuff, and my goal is to build a dedicated ebook distribution device that provides a standard cataloging API that allows direct integration with reading devices, and I'll be talking about that a little bit more later. I wanted to be able not just browsing of the collection that the device provided, but also searching. I wanted to make it easy for the operator to add new books to the collection, right? And the hardest part about adding books to the collection, it's not hard to add books to a collection if you're going to have just a browsable collection. But if you're going to have a searchable collection, adding books is harder. So things I needed to learn was the OpenWRT Linux-based router distribution. I'm going to talk about that in a minute. I need to learn about Atom syndication and something called the Open Publication Distribution System, SQLite database software, the Bottle web framework for writing web applications, and something called the Mako templating system. And I'm going to be talking about all these various bits of technology and how they all fit together. So here it is. Here it is. The fact that I'm holding it in my hand right now and there's no wire sticking out of it means that you can't connect to it. Up until about 15 minutes ago, my plan was that I would show you the picture here and tell you how to connect to it, but then I bricked it while the previous speaker was talking. So you can't connect to it right now because it's here in my hand. I expect it'll take me about 15 minutes to fix it when I'm at home, but I can't really fix it right now because of the infrastructure I need isn't easily available. This is a Unix-based networked file server, which, if you're like me and you grew up learning about computers on Vaxxon, is really scary. This is a TP-Link TL-MR3020. It has a little brother that's made by the same company that's even smaller, that has basically the same functionality. This has 32 megabytes of RAM and a tiny 4 megabyte flash file system in it, which is just big enough to boot off of. It comes from the vendor with some pretty basic router software on it. It's a wireless access point. But it's really easy, and like a lot of routers nowadays, there's an option for upgrading the firmware on the device. And one of the things that makes this one unique from most routers that have the option for flashing new software onto them is that this one isn't locked, so that you can load anything you want onto it. So it's really common for people to get things like this and scrub the vendor's distribution software off of it and install OpenWRT. And OpenWRT is a Linux-based router software. It's a custom distribution of Linux that's been built for embedded systems like this. It's got the Linux kernel and a basic set of utilities that you need to boot it and to get the routing working, right? So all it can really do is move packets between the wireless access point and the wired connection. So what it's got is it's got a wired connection, which you'd plug into your wall if you wanted to. It's got power, and it's got a USB port. They advertise this as a 3G Wi-Fi. It's like a low-rent MiFi kind of thing. And what you do is you take your the 3G wireless access point that you get from your cellular provider, and you plug it in here and turn it on, and suddenly it's providing wireless through your 3G modem to the local area. But what we do is, this is an 8 gig file system that I've plugged in, just a USB drive. Okay. So like I said, when you're connected to this, you're not connected to the internet. So this is the hardware, and it's running Unix. Well, it would be running Unix if I hadn't bricked it 15 minutes ago. Now, the thing about ebooks and ebook distribution is that there's a standard called the Open Publication Distribution System, and here's a little bit of it. OPDS is a standard format. It's a specialized version of the Atom syndication format, so it's like a fancy RSS feed, basically. This is one entry. An Atom feed is a collection of entries all wrapped into a wrapper package called a feed. I'm not going to bother showing you that part of it. This is the entry for one ebook, The Prisoner of Zenda by Anthony Hope. It's a really good late 19th century Victorian adventure novel that's been turned into about 6 different movies, some of which you've watched and never knew that they were related to The Prisoner of Zenda. The interesting bits is OPDS says that every entry is supposed to have a unique ID. You can see it there on the third line. It's the UUID A57A1, blah, 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 blah. OPDS says that technically that UID, the ID for the book, is not supposed to change if you've copied it and put it on a different storage device. And that'll be significant later when I show you what this all looks like. It's got an update time. It's got the author of the book. It's using Dublin Core for some of the bibliographic data. So this book is in English. It was originally published in 1894. And then there's a couple of links there. The first link is an image file. It's a cover file, a cover image, so that can be served by your reading device, show you what the cover looks like when you're browsing in the store. And the second one is a link for actually acquiring the book. The rel attribute on links tells you what kind of a link it is. So the first one says it's an image, an OPDS image, and the second one is an acquisition link, opdsspec.org/acquisition. There are 2 different kinds of Atom OPDS streams that are possible. There's a navigation stream and there's an acquisition stream. Okay, and an acquisition feed contains entries that are actual ebooks, and that's what you see here. This is a book that says this is how you acquire the book, and here is a link that links to the book. Okay, and this is an EPUB book. If I also had it available as a PDF and as a audio file. Those would be extra links here that would have the appropriate types so that the reader can say, you can get the EPUB, or you can get the PDF, or you can get the audio file. A navigation feed is got exactly the same kind of structure. It's a collection of entries, but each entry does not describe a book. It is a link to another feed. So you can build a hierarchy of navigation feeds. So at the top level, you'd have a navigation feed that says, here's, browse by title and browse by author, and a link that says, or you could search it. And then you look at the browse by title list, and that would be a list of all the titles, and that would be an acquisition feed that would give you each of the books. If I go browse by author, that navigation, the top level navigation feed would link to a navigation feed that says, well, we've got some books by Anthony Hope, and we've got some books by Jane Austen, and we've got some, books by Raymond Chandler, and so on. And so those are each. So that's another navigation feed, and then each of those navigation feeds each of those author links would link to an acquisitions feed that would give you information about the books, the individual books that are available. So that's OPDS, the first piece. And it's fairly straightforward. I mean, it's like, it's XML. It's not hard to read if you're not afraid of angle brackets and stuff. The next piece is SQLite. SQLite is a really simple, configuration-free, single database system. It supports most of SQL, the database query language, including the data definition language. It's open source. A lot of applications use it for storing complex configuration data. Apple uses it for storing system configuration data. If you have a Mac and you're looking around in your system libraries, you'll see database files, and it'll either be .db or .SQLite, and that's data. And that's just because it's easier to store data in the SQLite file and then run queries to get configuration data out. And in fact, some of the dedicated e-reading devices, the Sony and the Kobo, both store metadata about the books on the device in a SQLite database. And that's how the device presents information to you and makes it possible for you to search the content on your device while it's in your hand. And it's also the interface between your device and the desktop interface that you're using for syncing content. Okay, so when you plug your Kobo or your Sony device into your laptop and fire up the desktop app and copy a book over, the book file gets copied over, and then the desktop app updates the SQLite configuration data to say, here's a book, right? And this is with the author information, all that kind of a thing. Most languages have SQLite APIs in a standard library that's available, or is a well-supported add-on module that you can download for easily. My preferred language is Python. Python is a really cool language that's a lot more complex and rich than you might think by looking at it. So here's a SQLite query that gives me a list of the authors in my database with the number of books that are available from each author. And then the second thing here is a function that says, give me the list of authors. The con parameter is a database connection. So I run this query on the database connection and then loop over the return results. Running the SQL execute command generates a Python iterator, which is something that just returns each item in a list-like object, one at a time, and then yield is a function that returns the current version. Python is really strongly influenced by Lisp in some of the stuff that it's doing, and the scheme programming language, and this is one of them. So author list is a function that returns an object that looks like a list, but it doesn't generate the whole list all at once and return a list, it returns a thing. And then you can say, give me the next one, give me the next one, give me the next one, in a really simple way. And you will see in 2 or 3 slides what that looks like. So you can see here that, in my query, I'm actually selecting. I was looking at this the other day when I was getting my slides ready, and I realized, oh, I'm actually doing more in this select than I really need, because I never used the UUID for the author. But it's like we've got author IDs and names, and then how many titles there are, and it's the amount of SQL that SQLite supports is actually really far richer than I was expecting when I started. But it's really handy for the work that I'm doing. The next piece of technology is Bottle. This is one of the things that I had to learn the most about. It's been a really long time since I've done web programming, so web application development frameworks are for me, a new thing. And Bottle is a framework for developing web-based applications in Python. It's described as a micro framework. It doesn't do everything you need to do, but it does some of the really simple stuff. And this is about Bottle. This slide is about Bottle, but it's also about some of the really advanced things that Python does. There's a video on YouTube. It's about 15 or 20 minutes long, and it's this guy that just is like reviewing a half a dozen different frameworks for writing web applications in Python. And he said, and Bottle was the one that I picked after watching this video, because that was his preferred one, and he made a really compelling case for it. Unfortunately, right now I don't have the link for that. I'll have to find that and put it up. So the way this works is you build your application in pieces, and you've got handlers for different URLs. And the way you associate a handler with a URL is with this @root thing that you see here before each of the functions. And this says that if somebody asks for server name /author, then that's handled by the author list function. And if somebody asks for /author /something, that's handled by the author handler. And that extra parameter at the end of the URL is passed into the function as the AU parameter. And the way that this is being done is, this is not, unlike C and other languages, there's no preprocessor. Python is compiled on the fly when you load things up, and the @ sign is a little bit of magic syntax. These are called function decorators. So what this means is that I've actually defined a function called root. And the root function is associated with the URL /author. The root function takes two parameters. It takes the URL /author, and it takes a function to call when that URL is requested. And what's happening is that the compiler is seeing the @root and is building the appropriate syntax. So this is a kind of like a Lisp macro for generating a function to call this function. It builds a wrapper around author list and another one for author. And so it separates out the processing of the URLs from the handlers, but it ties it together as well. So instead of having a table somewhere in your code that says with two columns, where you've got a column with URLs and a column of handler function names, and then that's up here, and then all your code is down there someplace else. This puts the handler code right beside the assignment of the handler to the URL, and then it's built at runtime when this is loaded and compiled. And these are really simple functions, okay? So in the first one, we query the database to get the author list using the function I just showed you in the previous slide, which was 2 lines long. And then I pass that list, that iterator thing, to this cat render function and say, here's the author browse template. Please fill it in with the list of authors. And the second one is a little bit more complicated. So that's Bottle. There's a little bit of magic here as well. That DB parameter is special, but that's the micro format. And then so once I've got all this, then later on, I assemble all of the different pieces to build an application, and then there's like a one-line call that says, run my app. You know, if you're familiar with doing web programming, this is probably really boring for you. If you're not familiar with web programming, you probably don't know enough. Then I've just confused you. Or inspired, that's right. Bottle makes it really easy to write web applications without having to worry too much about some of the technical stuff that normally happens. This is actually my second iteration of building this. The first iteration, I did all the URL parsing by hand because I'm old school and thought that's what one did, and then I went and did some research and found Bottle, and this is a lot easier. And here's Mako templating. Mako is a template system for Python. Writing template systems in Python seems to be the thing to do. There's like a half a dozen different ones or more. Mako is really popular, and this is the template for the list of authors. And again, this is taking advantage of Python's dynamic code generation facilities in a different way from Bottle. Bottle was using the dynamic code generation facilities of the function decorators to associate URLs with handlers for those URLs. This is using the dynamic code generation to build functions that return formatted templates for dynamic content. So what Mako does is I'm skipping all sorts of setup and things in all of these things, but this is almost the entire file for generating a list of entries with one entry for each author that's available through the system. So you can see here, I'm saying here's the author browse.xml template, and here's this cursor parameter, which is the list object that I got back from my author list database query. And here is where I'm using them. So this looks like XML, except for the stuff that's highlighted in gray. And the percent signs and the dollar curly bracket stuff. So any percent sign is Mako for way of introducing a line of Python native code, and the dollar curly brackets that you see are expressions that are evaluated in line. And I did need the UUID after all, I forgot. So this says, for each author in the cursor, generate an entry with the UUID for the author, the name of the author. I'm fussy about whether an author has one title or multiple titles. So I check the title count to do that. I say how many titles he's got. And then I give a link that links to the URL for the acquisition feed for the list of books by that author, and you can see that this link, it's cut off at the end here, but this is a navigation feed. This entry is a navigation entry. This is linking to something that is not a book, it's a list of books or a list of navigation feeds. So that's the hierarchy that I talked about before showing up. And this is also one of the really great things about the way SQLite and Python integrates is that when SQLite returns a record from the database, it looks like a Python dictionary. It looks like a record in the Python language. So I can use the standard sort of keyword references for accessing the fields in database record directly in a way that looks like Python. So this is really easy for someone, as a Python programmer, this is easy to read without understanding anything about SQLite. In fact, I could rip out the SQLite and put in a version of the back end that was based entirely on just normal sorts of Python tables and dictionaries, and this code would work without being changed at all. Except it wouldn't be as dynamic, obviously. And this gets returned to the user's device, and the user can browse through the list of authors, and I'll show you that in a minute. So this is actually not a text file that's interpreted at runtime. When this is loaded by, when I initialize the Mako templating system and load this file, this is stored as an XML file, like I mentioned in the previous slide, but it gets loaded and compiled into Python native code. So Python takes this and turns it inside out, so that the stuff you see in gray is the stuff that is being interpreted, and the stuff that's not in gray, you know, the entry and ID and title and all the tags and things, is embedded in quotation marks in a Python code. So Python takes this, turns it inside out. So this is not being interpreted as a template on the fly. It's being read as executed as Python that's spitting out bits of the text. So you get really fast page generation once the system loads. The first time you try to access a page, it's kind of slow because it has to compile the Python code when it loads it. But once it's been compiled, it's really fast page generation, which is important because this is small. It's only got 32 megabytes, right? So I had to pick small pieces of technology to implement all the various bits, which was an interesting challenge. Now, in the abstract for this paper, I made promises about talking about the administrative interface for this and how you load books into it, and all that kind of a thing. I don't have any of that done. It works fine. You can, if I hadn't bricked it, you could all try to connect to it with your devices and browse the collection of 3 books that I've got and download something and read it on whatever you happen to be sitting in front of, and it would work just fine. But it turns out that adding books is far more complex than serving books, because I need to think about issues surrounding authority control for author names. An EPUB ebook file is basically just a web page that's been wrapped up in a zip file with some metadata. An EPUB file is a collection of HTML files, a collection of image files, some cascading style sheets, and 2 or 3 metadata files that are all bundled together into a zip archive and then served. And there's some standards about what goes into the metadata and what files are required and not. So what I really want to do in terms of being able to load a file is take an EPUB file and hand it to the system and have the system parse the EPUB to get the metadata out, rather than have the administrator, the operator of the dice, type all that stuff in. The problem is that all of these other bits of technology that I built the server on for downloading ebooks existed. Python's got a really rich standard library and collection, and a really strong community for developing third-party libraries for doing things. So reading a zip file is easy because there's a standard library for reading zip files in Python. There are a couple of modules for reading EPUB files and parsing the content in EPUB files, but they're really crappy. So I have to write my own. And I can mostly read an EPUB file, but I'm not at the stage where I can, generate the whole user interface for the administrative interface and that sort of a thing. So I'm not there yet. But it's on the list of things that I'm going to do as soon as I can unbrick my device. So this is what it looks like for the user. I left, in order to not fiddle too much with things, I left my phone at my chair, but when I started this, I knew that most devices have a way of connecting to a store, right? If you've got a Kindle, you can connect to the Amazon store. If you've got a Sony, you can connect to the Sony store. If you've got a Kobo, there's a Kobo store. You're detecting a trend here. And most of the devices now that have wireless support will actually let you browse websites too. I hadn't looked, when I started this project, the e-reader that I had, the dedicated e-reader device that I had was a first or second generation Kobo, so it didn't have wireless in it. It didn't have a lot of that kind of functionality. And Kobos are really great, cheap starter devices, but they're not really very good in terms of, they don't have the rich feature set that more upscale devices like the Kindle and the Nook and the Sony have. So it turns out that for most dedicated devices, they have a store that you can connect to, but there's no actual, they don't support the ability to connect to an arbitrary store. You can't say, well, yes, the Sony store is very nice, but I would like to connect to this other store instead. But for Android, and it's probably true for the iPhone as well, there are third-party ebook reading devices that do support configuring in your own catalog. So this is Aldeco, and FB Reader is another Android ebook reading software package that supports the same thing. So what I've done is, you can see on the left side of the screen, there's the My Catalogs page, and I've said I want to add a new catalog, and it's BiblioBox standalone, and here's the magic incantation, the URL for connecting to the catalog. So what happens when you turn this device on is, and some of you might have noticed this, if you were at the Hackfest the other day, you saw that there was an access point on the network that was available called BiblioBox, and I know that somebody had spotted here in the room after lunch. I plugged it in and turned it on, and at least one person in the room noticed that suddenly there was a BiblioBox access point here in the room. If you connect to that, you'll be able to connect, like I said, you'll be able to connect to the access point, but then you won't be on the internet, you'll be on this. And you'll get an address, an IP address for your computer from this network. And this network is the IP address 192.168.2.x, and this is number 1 on that network. And you connect to the URL OPDS. One of the things that's on my list is relatively low down is to get DNS working on this, so that this has the host name BiblioBox on the network that it's providing, so that it makes it a little bit more friendly to configure this stuff. And then once I've added the catalog to Aldeco, I can poke on it, and here's the catalog route. I can browse by title, or I can browse by author. This is a navigation feed, as I said, and if I say I want to browse by title, then you see something like this, with the 3 books in my collection, Anne Radcliffe and Anthony Hope. And you can see that there's 2 of them have download buttons and 1 of them doesn't. Well, and you can also see that we've got the cover images, right? The cover image is the link that you saw in the feed earlier. And the reason you don't see the download link, actually you see 3 books and 2 of them have green boxes that say downloaded. And that's because the UUIDs, the IDs for these, the universal IDs for these books are universal IDs for books that I previously downloaded from the system, so it knows I don't need to download that because I've already got it. So, people keep asking me, why do you want to do this? Because this seems pretty simple, and it's actually kind of restrictive. I'm not sharing files, I'm sharing ebooks. Now, I can share PDFs and I can share audio files as well. But it's And this is one of the things that Jason has been running into too. People asking, well, why are you doing this? You know, and the story of the person teaching English in a park somewhere, the idea of having a fully disconnected, local network in the literal sense of the word local, with no tracking of what's going on the device in a protest park, for example. I mean, when I started working on this in the spring, the Occupy movement was still a really big thing. It's still, you know, there's still stuff going on now, but it's not as big as it was then. So having Occupy libraries of ebooks was something that was the kind of thing that we're looking at, and it's completely disconnected from the infrastructure. Going camping. One of the biggest challenges with ebooks that I keep explaining to people is that if you've got your e-reader full of books and you're going to the beach with your girlfriends for, you know, a week of sun, and you finish reading a book. This is a friend of mine ran into this a couple of years ago. She got an iPad and was loving reading books on the iPad, and she went to the beach with her friends, and they wanted to swap books. And it's like, well, I can give you the book I just finished reading, but I'm also giving you my entire library. So having a standalone ebook, this is basically a standalone ebook sharing device. So you, instead of loading everything onto my iPad, I load it all onto this, and then it's at the park, at the cottage, wherever. And you know, the device will run. It fits into a small box, and it'll run for 15 or 16 hours with a battery with no connection to any infrastructure at all, which is all pretty amazing. So that's why I'm doing it, and because I was feeling decidedly ungeeky and I needed to do something to get back into programming, and I wanted to learn a bunch of stuff, and this let me do that. And ebooks are a particular interest of mine. So, and that's it. Does anybody have any questions? Someone's running for a mic.
When I tried to do an OPDS catalog for my MR3020, because I'm a very stupid man, I could not make one from scratch like you did, and I constantly ran out of memory. So I wondered if you had, and the machine would just crash and reboot, and I wonder if you had problems optimizing your setup. Did you ever run out of memory and crash when you were writing this stuff, or was it already small enough to begin with?
Everything was really small.
Okay, so there's no terrible refactoring to do. Okay.
That was one of the things is, well, what were you using for your web server?
Geez, I don't even remember.
You don't even remember. See, that's the thing is that some of these bits already exist in various incarnations, but I'm not going to try and install an entire PHP stack onto this. So I'm using a really tiny web server called Hiawatha with the most politically incorrect logo you have ever seen. Oh my God. It's Hiawatha, Python, SQLite is really tiny. It's been optimized for small devices like that. Mako is, to be honest, Mako is probably the biggest thing that I'm using. And you know, I've got a library of 3 books, and only one person has ever connected to it before. So no, but I mean, no, I didn't have. It's, you know, that's the kind of situation you were in, right?
Yeah,
so
it would crash. Nobody even connected. It
wouldn't
crash.
even connect. No, yeah, no, it was working fine. Yeah, no, I've had it. It's been plugged into my living room running for, you know, months, and you know, I poke at it every so often when I've got a spare minute. So yeah, it was about finding, and I actually want to thank Dan Chudnov. If you were at Code for Lib North in Windsor in May, that was when I had the first incarnation of this running, and it was running off of a static feed file that said, here's the 4 books that are available from the collection. And it was working just fine then with just a static file, right? It's like, it was the XML version of a web page that said, hello world. And it worked just fine. And you know, I took some time to chat with Dan, who knows far more about some of this stuff, or has had more recent experience with some of this stuff than I have about, you know, implementation choices. And so he reaffirmed the idea that SQLite and was probably, you know, a good choice for that. So yeah, it's about the core technologies. Does anybody else have any questions? It is available on GitHub. There's a few people that are following me, but That's one of the things I wasn't paying attention to, so I don't have a link for it on GitHub, but that'll go up in a little while. Good luck trying to install it on your own, because it's, again, it's one of those things where the code's available, but no one's ever actually used it but me. And even I don't necessarily know if I could reproduce the configuration I've got right now without spending far more time on it than I should. I don't have installation instructions. I've got programmer instructions. It's DJ Fiander. If you want to find me, my name is DJ Fiander. Everywhere. Except for the places where I don't want you to find me, and then it's something else, and I'm not going to tell you what that is. Is there anything else? Okay, thank you very much.